The coordinate crisis. Humanoid robots using absolute coordinate mapping lose 30% of their precision the moment their sensor calibration drifts by a single degree. Most developers assume that telling a robot exactly where to put its hand in three-dimensional space is the most direct path to success. In practice, this creates a brittle system where the model has to be perfectly synced with its physical environment every millisecond. NVIDIA's GR00T N1.7 technical report suggests we have been looking at the wrong variable. By abandoning absolute positions for what they call relative action space, the error rate in uncalibrated environments drops significantly. This shift from where to be to how much to move is the core of the new N1.7 architecture, and it starts with the delta control mechanics. Delta control mechanics. In version N1.7, the policy does not output a target joint angle like 45 degrees. Instead, it outputs a delta, or the change required from the current state, such as plus 0.05 radians. Think of it like giving directions. Absolute coordinates are like telling a driver the exact latitude and longitude of a turn, which fails if the GPS is slightly off. Relative actions are like telling the driver to turn the wheel 10 degrees to the right. This local feedback loop allows the robot to compensate for mechanical wear and sensor noise without needing a global map. The paper shows this approach requires fewer parameters to achieve the same precision as previous absolute models. This efficiency becomes even more obvious when we look at the latency and jitter benchmarks. Latency and jitter benchmarks. The most striking data in the N1.7 release is the reduction in high-frequency jitter. Traditional absolute models often suffer from a micro-stutter effect because the model is constantly overcorrecting to hit an exact coordinate that might be shifting due to sensor noise. The relative action space method smoothed out these trajectories by 12% in the standard box lifting test. However, there is a catch. Skeptics point out that pure relative movement can lead to drift over long durations, where small errors accumulate until the robot is completely off course. NVIDIA addresses this by layering a low-frequency visual correction over the high-frequency relative motor commands. This dual-rate system maintains stability, while proving that the robot can generalize across hardware it has never seen before. Generalization across hardware. Because the model is training on deltas rather than fixed dimensions, the N1.7 weights are surprisingly portable. In one internal test, the same policy was deployed on 3 different humanoid frames with varying limb lengths and motor torques. The absolute position models failed immediately on the different hardware because their internal maps did not match the new limb lengths. The relative model, however, succeeded in 60% of the tasks without any fine-tuning. It simply applied the same proportional changes to whatever motors were available. This indicates that we are moving away from models that learn specific bodies and toward models that learn the fundamental physics of balance and manipulation. This leads us to the most important technical takeaway from the N1.7 update. The hardware-agnostic shift. The move to relative action space in GR00T N1.7 signals that the era of bespoke, one-off robot training is ending. By focusing on deltas as seen in the delta control mechanics and solving the micro-stutter issues found in the jitter benchmarks, NVIDIA is building a physics engine for neural networks rather than just a control loop for a specific machine. This changes the goal for builders from collecting perfect coordinate data to collecting high-quality movement trajectories. For researchers, it means the hardware is becoming a commodity while the movement policy becomes the true asset. We should stop evaluating humanoid progress by how many tasks a robot can do and start measuring how little it needs to know about its own specific hardware to do them. Watch the upcoming Robotics and Automation Conference in June for the first third-party benchmarks on non-NVIDIA hardware. That will be the real test of whether these relative weights are as portable as the paper claims. Subscribe for more